Hi, good morning. My name is Dr. Sajid Anwar. I am from Department of Software Engineering, Prince Sultan bin Abdulaziz University, Al Kharis, Saudi Arabia. Today I'm here to present my conference paper with the title Challenges and Best Practices in Blockchain-Based Systems, an LLM-assisted empirical study of GitHub repositories. Here is the outline of my presentation. First, I will discuss the introduction of my presentation, my research. Then I will discuss the motivation, why I'm conducting this research. And then I will discuss research problem, and following the objectives. Based on such problem, I will discuss the objective. What are the objectives of this study? And then I will discuss a methodology. What are the methodology I use to carry this research? Following this, I will discuss results, a couple of different dimensions. Following this, I will discuss implications from different perspectives, academia, from industry, from research perspectives. And then I will discuss the limitations, some of the limitations of this work, and lastly I will pass some concluding remarks for this research. Okay, so as this study is about the blockchain based systems. Okay, so the blockchain development is now a software engineering problem at ecosystem scale. So blockchain development is no more a separate domain, it's a part of the systems, and now it's being considered as a software engineering problem. So it needs a software engineering based practices solution to deal with the blockchain based development problems. Okay, so the blockchain shifts software systems from centralized trust to decentralized, transparent, immutable architectures. So due to this shift, so now the blockchain based system is not same like we have the ordinary software systems. So there are different challenges. So this transition from centralized to decentralized, transparent, immutable architectures. So this transition introduces different challenges. So we need to understand first we need to understand what are the difference between the systems and what are those challenges and how we can cope up with these challenges. So this is the point of interest, the point of focus for today's presentation. So in order to get the real in-depth understanding of what are those kind of problems and what are the best practices to deal with them. So best practices not in terms of a theoretical knowledge, it must be in terms of the practical knowledge. Okay, so for this purpose, so we have the different open source platforms that publish the developed projects. So the statistics, the metrics related to those projects means any problems, any issues, solutions, like we have the Stack Overflow and different platforms. So, but for this research, we use a GitHub. So open source platforms such as GitHub, it records real developer frictions through issue reports. So it includes the issue reports and discussions, bug discussions, and most importantly, fixes. Means if the issue has been closed, then it will list down what was the problem and how it's been closed. Means from this closed issues, we actually get the best practices. So those best practices will not be as kind of someone's thoughts, someone has a theoretical knowledge. So those best practices will be from the actual implementation, drawn from the actual implementation. So this study mines blockchain GitHub repositories and uses an LLM to extract challenges. Means what are the challenges that the blockchain based systems we can face in the blockchain based systems, and what are the best practices to deal with those challenges beyond keyword level topic modeling. So it provides empirical evidence. So the empirical evidence is based on the practical data, not only not on based on the some sort of, you can say, the interviews or the surveys, because both are some sort of a thoughts of some individuals. Maybe it's from the experts, but still it's a theoretical knowledge. But this evidence, this empirical evidence that we can get from this study, or maybe all the studies that's performed based on the GitHub data, that's evidence is from the practical knowledge, it's from the practical data. So evidence from real blockchain based development work, not only survey opinions or narrow smart contract based studies. So what is the motivation? Why I'm conducting this research? So what is as I said before, the blockchain based systems actually is transition. It moves the the normal software engineering from centralized to decentralized and some other decentralized platforms. Okay, so the blockchain faults are not the ordinary software bugs like in the normal software systems. We may have some sort of, like you can say, the variable declaration issue, or maybe some small range from small syntax issues to the maybe the some sort of logical issues, but still those bugs, those faults is not same than we deal with the blockchain based systems. Okay, so therefore we need some extra measures. We need to understand what are those kind of bugs, what are the reasons for those kind of bugs. If we understand the reasons, if we can understand the bugs, then we can understand the solutions as well. We can make the solutions. But without understanding these things, we cannot make a solution. So defects can cause irreversible financial and operational losses because deployed blockchain logic is difficult to change. Means when we deploy the system and it involves blockchain, so then if there's any issue, then it becomes challenging as compared to the normal system. Even though it's the normal system, there's still a challenge, but as compared to the normal software system, the blockchain based system is actually more challenging to change, to maintain when it's in the operation. Okay, so that's why we need to make a extra measures. We need to have a extra conscious, extra perform extra measures to handle, to deal with the issues that's related to the blockchain based concepts. So developers face domain specific problems such as like node synchronization, gas usage, token bridge, key handling, wallet behavior, and consensus latency. So you can see these are all these issues. This is not we face in the normal software systems. So this is specific to the blockchain based systems. That's why when we have the specific issues, we need some specific measures. So prior GitHub studies were narrower, often focused on Ethereum smart. Yes, there were some studies performed, but they focus on portions of this problems, pieces of this problem, like Ethereum smart contracts. Yes, smart contract is a major element of blockchain, but it's not a whole blockchain. Or they use the statistical NLP based methods to, like when they crawl the data, then they just use a NLP approaches to just get the information, just get the conclusions from the data. So definitely they have some contextual problems in the using NLP techniques. So in the blockchain based systems, the defects have a high cost. So it has a complex technical discourse, and ultimately we need a scalable evidence, the evidence to deal with these kind of issues. So the motivation is to convert developer issue history into a practical engineering knowledge. So this is the main motivation behind this problem. So what is the such problem? So existing evidence is fragmented and often too shallow for real blockchain based development systems. Developers repeatedly report blockchain specific issues, but the existing work lacks in like scope gap. So they just focus on small, as I said before, on the small pieces. The method gaps, so they apply traditional LD or topic modeling techniques to process the GitHub data. And lastly, and most important, so the process rarely extract resolution based best, as I said before. The best practices people discuss, but those are based on the surveys, based on the interviews, but not based on the actual development, actual knowledge, actual practical knowledge that as you can extract drawn from a GitHub based data. So based on it, we design a search question as follows. What technical challenges and best practices emerge from large scale blockchain GitHub issue data? So this is actually a research problem, or you can say the search question that we actually try to address in this presentation, in this study. So what are the objectives of this study? This study aims to collect and analyze the large GitHub issue data set for blockchain related repositories, to quantify issue distribution by programming languages, and which means these are some descriptive statistics, means which programming language actually has a more kind of issues and which programming language has a less resolution time and more. So we'll discuss inshallah in results. To identify recurring challenges using LLM assisted thematic synthesis, and lastly to derive best practices from successfully closed community issues. So expected outcome: an evidence-based foundation, knowledge base for Web3 developers, educators, tool builders, auditors, and researchers. So this one we are actually expecting from this study. So this is the research methodology we use to carry on this research. We start with the data collection. So we use GitHub REST API to get the mine or get the data, and in the data we try to get the, in the query we mention the name, descriptions and topics, okay, and ultimately we get 337,161. Okay, so this is the number of issues we got from this based on our query. After this, we perform a manual filtering. Okay, so before performing auto filtering, for manual filtering, we remove some sort of, we perform basic filters like the issues that has a more 0-star repositories, we remove it. So remove 0 issue reports means if they have any repository have a 0 issue, just remove it. Okay, and we only kept the English language issues. Any issues that is other than the English language, we simply remove it. And this is done, manual filtering is done by the domain experts. After this, we performed auto filtering. Okay, so we use Python scripts to do this auto filtering. So we remove any bot PRs, and we keep the issue that is the body, means where the description is more than 50 words. We just get the, means it must have some substantial knowledge so that we can it can be useful in the synthesis and analysis. So that's why we put this limit. And issues must have some domains, keywords like smart contract, census, token, wallet, gas, and again the English language. So after performing this manual filtering and then auto filtering, so we actually get, at the end we get 80,274 issues, which is 23.8% of the total issues. You can say around one fourth of the issues were retained for the analysis based on this manual and auto filtering. Then in the analysis, we actually do a two type of analysis. One is simple descriptive analysis, means based on all the issues, we try to understand what kind of languages are used in the issues, and then we try to understand the open and closed and issues ratio, and then how much time a particular language issue is taken to resolve it. So this is just the basic descriptive analysis. Then we perform in-depth analysis using LLMs. We use Llama 3.3 with 70 billion parameters. So based on this, we extract challenges, the 11 challenges and 9 best practices. So after identifying this analysis, identifying these challenges and best practices based on the Llama, we also do some manual verification by using some domain experts. So and perform a interrelated reliability. So it was interrelated reliability fulfilled the criteria. So this is the methodology we use to carry on this search. So comes to the results. So first I will discuss the descriptive statistics like programming language distribution. So you can see from this, so around 22% of the issues used Go programming language, 19, and again 22% is the Rust. 19% the Rust and 18% TypeScript. So these are the top three, and 22%, and the others are small portions. In total, Go, Rust and TypeScript actually is around 60%, just three languages. Okay, so just these three languages actually used in more than 50%, around 60% of the collected issues. Okay, so from this analysis, we can perceive that, we can understand and conclude that core systems and DApp tooling stacks carry most visible blockchain maintenance work as compared to the other kind of languages. Okay, in terms of issues and resolution time, so you can see just 13% of the issues from the collected issues is actually open, and 87% has been closed. So it's very huge number. So means issue raised and then it has been closed, which is, you can say, around 86% issues has been closed. Regarding the resolution time, so you can see from here the TypeScript issues take on average 100 days to resolve the issue. But on the other side, C++ take 157 days to resolve the issue. Okay, so this actually helps us to understand which language is actually mostly used in the blockchain-based systems. So higher abstraction application tooling tends to resolve issues faster than lower level consensus and networking code like Go and C++ and so on. So this was the descriptive analysis, and now I will discuss about the challenges. So as I said, we've used Llama to identify the challenges. So actually we identified 11 technical challenges, and top fives are this one, like node synchronization, which is appears in 80% of the issues. Token management appears in 61% of the issues. Infrastructure and performance is actually 48%. Gas optimization 37%, and key management 30%. So these are the top 5% issues. That percentage is more than 30% in the issues. Regarding the best practices, we identified 9 best practices. Okay, and this is, as I said before, based on the closed issues, because in the closed issues, people, when they close, they mention that what was the solution, how we what practice we opt, what implementation task we perform, and then we are able to resolve the issue. So this is based on the close. That's where it has more practical significance. So we identify 9 best practices, and the top 5 are as below. So the node configuration is appears in 53% of the studies, and code review in 51, error handling in 42, token verification in 28, and storage in 80% of the studies. So these are the top 5 best practices. Okay, so move on. So what are the implications? Means what is the addition? What is the addition of this study in the body of knowledge? So the implications of this study is multifold. So this first is in the context of education. Means from this study, based on the language distributions, based on the resolution time, we can understand. So from the education perspective, like the Go, Rust, and TypeScript are actually the most widely used in Web3 development. So it must be prioritized when we are in the university, when we're designing a course related to the blockchain, or maybe we need to more focus, maybe we need to offer more courses related, because this is the most widely used languages in the blockchain based system. So it has an implication in terms of tooling. So we need to prioritize static analyzers, security scanners, and test frameworks for the 3 dominant languages. Means the people who are interested to develop a tool, so they must need to understand. So these are the languages that are most widely used. So we have to build the tools that focus on those 3 languages. Lastly, in terms of governance, use issue closure rate as one signal of project health, maintenance quality, and technical depth control. So this actually help out to understand how good is our project. So yes, this study has produced good results, and it has a very good but still it has a very good implications and multifold, like education, research, developers, but it still has some limitations. So the keyword based retrieval may miss relevant repositories and may misclassify some issues content. So LLM themes can be influenced by prompt design, like the theme, the sampling choice, and the search and interpretations. GitHub only, because we only focus on one. So other open source data is actually we ignored it. So that's why this data limits generalization to private and non-GitHub projects. Lastly, LLM outputs are probabilistic. Multi-run consensus and fixed seeds should improve the reliability of this study. Lastly, what's the conclusion? So in this study, we identified 33761 related issues related to the blockchain-based systems on GitHub. After filtering both manual and automated, we shortlisted more than 80,000, which is more than 23% issues of the total collected issues. So based on this one, we understand, we revealed that around 60% issues are from these 3 languages, Go, Rust, and TypeScript. This study identifies 11 challenges and 9 best practices. Okay. So in future, we plan to perform longitudinal tracking, cross-platform issues data from GitHub, Jira, and automatic classification pipelines for real-time developer support. So that's all for my presentation. Thank you very much.